So, ladies and gentlemen, we are doing 10.2 and 11.4. They do go together. They both have to do with arcs. We're talking about arcs and chords for this. A minor arc is under 180. A major arc is over 180. And a semicircle is exactly 180. Okay? The measure of a minor arc is defined by the measure of its central angle. Central angle goes right through the middle. The measure of a major arc is 360 minus what's left over. Okay. Arc addition, if two arcs are adjacent to each other, you can add them together and your sum is the whole thing. Okay. All right. Let's look right here. We're determining whether these are minor arcs, major arcs, and what their arc measure is. So we've got the arc. We've got minor, major, and I'm going to put SC for semicircle, but it's on your paper. And we've got arc measure. Okay. The first thing we've got is MN. Is that minor, major, or a semicircle? Minor. Okay, what would the degree be of M to N? 70. Okay, let's look at NQ. So we've got N to Q. What do you think, minor or major? Minor, so, okay. Now, the tougher part, am I spelling minor right? No. Okay. M-I-N-O-R. Okay. So, how are we going to figure out the degrees of this? We don't have them all written there. Yes, Sam?
Well, since you have 35, since you have half a circle, you know obviously that's going to be 180.
So I know this is half a circle right here.
Half a circle.
Okay, that's 180.
Yeah, you already have 70 and 35, so if you just add those, you get the 30. If you add and then subtract.
Subtracting, what do I get?
You get.
What do I get for this middle one?
75.
Okay. I took 180 minus 70 minus 35. Okay, but I don't want this one. I want the whole thing. So what am I going to get?
110.
110. And is 110 a minor or major arc?
Minor.
Okay. NQR. What are we confused about? Let's stop. So we found what? N to Q, and this is N to Q.
How do you know that that's 75?
I knew this was 75 because I knew this whole thing added up to 180. Okay, so 180 minus 70 minus 35 gives me 75. And then I just added those two together. We're good? Okay. All right. So, what is NQR? And is there a reason we're talking while I'm talking? Do you guys need help with something? Okay. What is NQR? NQR is a semicircle. And so what's the degree of a semicircle? 100. Oops. 180 degrees. Make sure you put these degrees in here. Okay, our next one is MRP. Arc MRP. M to R to P would be major. Okay, I like to draw it on here so I know what we're talking about. MRP is a major arc. Okay, so what is the degrees of this major arc going to be? We know from M to Q is how much? 180. M to Q is 180. So we're going to add the 35 to get the whole thing, and that's going to be 215 degrees. why MRP is listed twice. We're going to skip the second one. And we're going to go to QR. What's the arc of QR? Major or minor? Minor. And what are the degrees? 70. Okay, what about MR? Major, minor, minor, because it's under 180. And how many degrees? 110. 110, good.
Wait for the M. RP is at 250.
Yes, it is. Okay, arc Q, MR, major or minor? What is it? So point, go Q, MR. How much do we get? Major or minor? Is it over 180 or under? Major. And then how many degrees? How many degrees is this little piece right here? 70. And how do you know? Because it is a what? Vertical angles. Okay? So I want to know what I'm looking for is QMR. So I do 360 minus 70, which gives me 290. Do we feel like we get the point? Do I need to keep going? Okay, let's move on to the next one. We've got a lovely shape like this. We've got A, B, C, D, except yours is, I'm going to redraw this. Okay, we've got a circle. We've got A, C, and then D, B. And it says this is 2x and this is 6x. What can I do? So what does this form?
Add them together.
Add it equals, set it equal to 180. 2x plus 6x equals 180. So 8x equals 180. So what does x equal? 22.5. But it didn't just ask us for x, it said to find all the measures. So what's 22.5 times 2? You should have your calculators. It is 45 degrees. Okay, and what is 6 times 22.5? 135. So what is this angle right here? If this is 135, what's this? It's the same because of vertical angles, right? And so that would also be 45. Okay, let's look at B. We've got a circle. We've got D, B, and then we've got A, and then we've got C. This is 2x plus 8, and this is 72 degrees. What do I do? Add them together equals 180. 72 plus 2x plus 8 equals 180. So I get x equals 50. And then I've got to plug everything back in, right? So I know this is also 72. We agreed? Okay. Then we know this is 108, and this is 108. All right, let's go to the back. And we're going to be talking about 11.4. I'm going to pause for 1 second so I can open it. All right, ladies and gentlemen, we're looking at 11.4, circumference and arc length. We know the circumference of a circle is pi times diameter, or 2 pi r. And this is a ratio we're going to use for finding the length of an arc. We're going to use arc length of AB over 2 pi r equals the measure of the angle times 360. Okay. But we're going to do some easier problems first. We want to find the circumference of a circle with a radius of 17 centimeters. How do I do that?
2 pi r. And I mean pi, 2 r pi.
So 2 pi r is circumference or pi times diameter. Do I have the radius or the diameter? Radius. So 2 pi times 17. And we can just leave it in pi form, 39 pi. 2 times 17. Okay, what about the next one? The circumference of a circle with a diameter of 14.
So where you
Circumference right up there. Or
Yes,
circumference?
just write pi right next to the answer.
Yeah, you just write pi right next to it. So circumference, its diameter is 14, so it's diameter times pi, or pi times diameter. Okay, again, you can stick it in your calculator and get the decimal approximation. Okay, we're going to skip these next ones because they're not even on your paper. And we're going to go to find the arc length. Okay, I know that the radius, I write r for radius, is 8. And I know this degree right here, the central angle we call it, or the degree of the arc, is 60 degrees. Okay, so I'm going to use that equation up there. The arc length, we don't know. It doesn't give me numbers out here. So I'm going to make that x. And I'm going to put that over 2 pi r. So 2 pi 8. And I'm going to set it equal to the degrees. Over how many degrees are there in a circle?
360.
360. So it's always going to be 360 like that. And then what do? Cross multiply. Yeah? So we get 360x. I'm going to do all of this at one time. I'm going to multiply it all together. So in my calculator, I'm going to write 2 pi times 8 times 60. And I get approximately, 3,001, 3,015.9. And then what do I do? Divide by 360. And I get that the arc length is approximately let's round it up to 8.4 centimeters. And we're doing the length of something, right? So we just use centimeters, not centimeters squared. Ready? I'm going to do another one just like this. Okay. Can somebody tell me what the radius is for this one? 11. And what's the degree that I'm looking for?
100.
Excuse me? 120 degrees. Okay, so how do I set this up? Do I know what the length of the arc is? So what do I put down? Okay. What do I put it over?
2 pi
11. Good. Equals 120 over 360. Good. Then I'm going to cross multiply and get 360x equals, and I'm going to multiply all that stuff together. Let's leave this one in terms of pi, so I'm not going to multiply it by pi. So I'm going to go 2 times 11 times 120 gives me 2,640, and I'm going to put the pi symbol. Okay, and then I'm going to divide 2,640 by 360. And I'm just going to leave it in terms of pi. So x equals 7 1/3 pi centimeters. You need to know how to do both ways. All right, we got 2 more problems, guys. We're going to find their circumference if we have the arc length. So we're basically going to work backwards. All right. We know that the degree is 40, and we know the arc length is 4.19. So I know the arc length is 4.19, so I put that on top, over 2 pi r, and I don't know what the radius is, equals 40 degrees over 360 degrees. And then I'm doing the same thing. I'm going to cross multiply. So I'm